When we think of cold, our minds might drift to the icy plains of Antarctica, a place where temperatures can plunge to a staggering minus 80 degrees Celsius. But on a cosmic scale, that's practically a summer's day. In the language of physics, cold is simply the absence of heat, a measure of how slowly atoms and molecules are moving. The ultimate limit, the absolute cessation of all motion, is a temperature known as absolute zero, 0 Kelvin, or minus 273.15 degrees Celsius. While reaching it is physically impossible, the universe is filled with places that get astonishingly close. So, bundle up as we embark on a journey to the 10 most frigid, mind-bendingly cold places in the entire universe. Kicking off our list at number 10 is an exoplanet known as Gliese 414 AC. Located about 39 light-years away, this behemoth is classified as a super Neptune, a gas giant significantly more massive than our own Neptune but not quite reaching the scale of Jupiter. Its atmosphere is a swirling vortex of hydrogen, helium, and other frozen gases, plunging to an estimated temperature of minus 150 degrees Celsius. The reason for this bitter cold is its vast distance from its host star, an orange dwarf that is already cooler and dimmer than our Sun. Orbiting so far out in the stellar system's frozen frontiers, Gliese 414 AC receives very little energy, leaving it in a state of perpetual twilight and deep freeze, a true giant of ice and shadow. At number 9, we find a truly strange celestial pairing, the planet WD 1856 plus 534b. What makes this system so cold is the star at its heart, or rather the ghost of a star. It orbits a white dwarf, the incredibly dense, Earth-sized remnant of a star that has exhausted its nuclear fuel and died. These stellar corpses are exceptionally faint, emitting only leftover heat from their former lives. Any planet orbiting a white dwarf is destined for a frigid existence. While this particular planet orbits surprisingly close to its star, giving it a warmer than expected surface, the environment it inhabits is one of profound cold. Imagine a solar system where the sun has been replaced by a dim, fading ember. Any world in such a system not huddled right next to the dying star would be unimaginably cold, a testament to the universe's final quiet stages. Our number 8 spot takes us 20,000 light-years away to a planet so cold it earned the nickname Hoth. Its official name is Ogle 2005 BLG 390 LB, and it's a frozen super-Earth about 5 times the mass of our own planet. Discovered using a clever technique called gravitational microlensing, this world is a truly inhospitable place. It orbits a cool red dwarf star at a distance more than twice that of Saturn from our Sun. The combination of a dim star and a vast orbit starves the planet of warmth, leaving its surface at a bone-chilling minus 220 degrees Celsius. At this temperature, any atmosphere would have long ago frozen solid, blanketing the rocky surface in a permanent layer of frozen nitrogen and methane. It's a silent, static world, a far-flung outpost of ice that makes the fictional Hoth seem almost temperate by comparison. For number 7, we don't have to travel to a distant star system. We just have to look at our own cosmic backyard, the polar craters of the Moon and Mercury. These are some of the most bizarre thermal environments in the solar system. Due to the very slight axial tilt of these bodies, the floors of certain deep craters near their poles have not seen a single ray of direct sunlight in over 1 billion years. These are known as permanently shadowed regions, or PSRs. Without any solar energy to warm them, their temperatures plummet to an incredible minus 248 degrees Celsius. That's colder than the surface of Pluto. These perpetual shadows act as cosmic cold traps, collecting and preserving volatile compounds like water ice for eons, making them prime targets for future human exploration and resource utilization. Leaving planets and moons behind, our number 6 spot is not a place, but the space between places. Welcome to intergalactic space, the unfathomable void that separates the great island universes we call galaxies. Here, in the near-perfect vacuum of the cosmos, the temperature drops to a staggering minus 270 degrees Celsius, just 3 degrees above absolute zero. The cold here is a result of sheer emptiness. With only a few hydrogen atoms per cubic meter, there's virtually nothing to hold or transfer heat. While space within a galaxy is warmed slightly by starlight and nebulae, the gulf between them is exposed to the raw, fundamental cold of the universe, a chilling reminder of the sheer scale and emptiness of our cosmos. The temperature of intergalactic space isn't random. It brings us to number 5 on our list, the cosmic microwave background, or CMB. This isn't a location but a faint pervasive glow of radiation that fills the entire universe. It is, quite literally, the afterglow of the Big Bang. Forged in the fiery crucible of the universe's first moments, this light has been traveling through space for 13.8 billion years. As the universe expanded, this ancient light was stretched and cooled, its wavelength shifting from visible light to the microwave spectrum. Today, it gives all of space a baseline temperature of 2.725 Kelvin, or minus 270.4 degrees Celsius. It is the oldest and most distant light we can ever observe, a fossil echo of creation itself, and the fundamental source of cold in the void. At number 4, we find a profound mystery etched into the very fabric of the cosmos, the CMB cold spot. While the cosmic microwave background is remarkably uniform, it's not perfect. It has tiny temperature variations which correspond to the seeds of galaxies and clusters, but one of these spots is too large and too cold to be explained by standard cosmological models. This cold spot is a vast patch of sky that is about 70 microkelvins colder than the average. What could cause such a significant anomaly? One leading theory is the existence of a colossal supervoid, a region of space over 1 billion light-years across, containing far fewer galaxies than normal. Another more tantalizing possibility is that the cold spot is a cosmic bruise, evidence of a collision between our universe and another bubble universe in a vast, undiscovered multiverse. For number 3, we take a detour from the natural cosmos to a place of artificial extremes, the Cold Atom Laboratory aboard the International Space Station. Here, scientists have created the coldest known conditions anywhere, reaching temperatures just 100 picokelvins, that's 1/10 billionth of a degree above absolute zero. This is a temperature so cold it is hundreds of millions of times colder than the depths of intergalactic space. To achieve this, scientists use a combination of lasers and magnetic fields to slow down atoms until they are almost perfectly still. In the microgravity environment of the ISS, they can observe a bizarre state of matter called a Bose-Einstein condensate, where individual atoms lose their identity and behave as a single quantum object. It's a place where we push the laws of physics to their absolute limit. Our runner-up for the coldest place in the universe isn't a place you can visit yet. It's a time. Number 2 is the distant, theoretical future of the universe itself, in a scenario known as the heat death or the Big Freeze. Over trillions upon trillions of years, the universe will continue to expand, cool, and decay. All stars will eventually burn out, leaving behind cold remnants like black dwarfs and neutron stars. Even the supermassive black holes at the centers of galaxies will evaporate through a process called Hawking radiation. Eventually, all matter will decay into a diffuse soup of photons and subatomic particles, separated by infinite distances in an ever-expanding dark cosmos. The temperature will asymptotically approach but never quite reach absolute zero. It is the ultimate end, a state of maximum entropy and profound, eternal cold. And finally, at number 1, we have the coldest known place in the universe, the Boomerang Nebula. Located 5,000 light-years away in the constellation Centaurus, this object is a protoplanetary nebula, a young, dying star in the process of shedding its outer layers, and it is doing so with incredible violence. Gas is being blasted away from the central star at a speed of over 160 kilometers per second. This incredibly rapid expansion is the key to its record-breaking cold. It acts as a cosmic refrigerator, a process known as adiabatic expansion. The gas cools as it expands, and because this expansion is so fast, it has cooled to an astonishing 1 Kelvin, minus 272.15 degrees Celsius. It is so cold, it is actively absorbing the energy from the cosmic microwave background radiation, making it the only known natural object colder than the afterglow of the Big Bang. From frozen exoplanets to the fundamental background temperature of space, from man-made quantum labs to the ghost of a dying star, our universe is a place of breathtaking extremes. This journey to the absolute depths of cold reveals not just cosmic curiosities but fundamental truths about the birth, life, and ultimate fate of everything we know. It forces us to ask, what other records, what other impossible extremes are still out there, hidden in the dark, waiting for us to discover them? The cosmos is vast and full of wonders, and we have only just begun to feel the chill.
Journalist sits alone behind the mic, sipping cold coffee. The studio feels like a graveyard. Lena, into mic.